Ever toss something in your Amazon cart at like 2 a.m.?
And half expect it to just like not work.
Right.
Like even the internet needs to sleep sometimes.
Yeah.
But it almost never does.
It never does.
And today we're going to find out why.
Yeah.
We're unpacking Dynamo Amazon's secret sauce for bulletproof reliability.
That's right. And we are going straight to the source for this one.
Okay.
Their 2007 research paper.
2007.
Dynamo Amazon's highly available key value store.
Love it.
This is the one.
Going back to the OG.
Straight to the source.
So the paper really dives into how Amazon makes sure that things keep running smoothly.
Yeah.
Even with failures.
It's all about making the right trade-offs.
Okay.
And in this case, they prioritize availability over strict data consistency. You're always going to be able to add that unicorn onesie to your cart, even if a server somewhere is taking a break.
I love that.
You know?
So how do they actually pull that off?
So picture a giant, well-organized flea market,
Right.
but instead of stalls, we're talking servers.
Okay.
They're using this technique called consistent hashing
Okay.
to distribute the data across all these servers.
So each vendor at the flea market gets their own little spot.
You got it.
Okay.
But then they take it one step further with virtual nodes.
Okay.
It's like giving each vendor
What?
multiple stalls throughout the market.
Interesting.
So that if one server goes down,
Okay.
its data is already spread across multiple others.
Got it.
And the market keeps humming.
Smart. I
Like
like it. Yeah. So the market is humming, data is organized. What happens when somebody wants to actually buy something?
That is where replication and sloppy quorums come in.
Sloppy quorums.
Dynamo keeps multiple copies of your data.
Okay. So multiple vendors have the same thing.
Yeah, like backup copies in case a vendor runs out.
Got it.
But they don't wait for every single copy to be updated before confirming your purchase.
Okay.
That would take way too long.
Right.
Especially at peak.
Yeah. 2-day shipping.
Yeah, exactly.
People are impatient.
They use this thing called a sloppy quorum.
Sloppy quorum. What is that?
So they found that requiring just 2 out of 3 replicas to confirm your order
Okay.
was the sweet spot.
Okay.
Fast enough for you, safe enough for them.
Got it. So as soon as 2 servers get it, I'm good to go.
Exactly.
That makes sense. That's why checkout at Amazon is so fast.
Exactly.
Right.
What if one of them's down?
What if one of them's down?
Yeah.
They thought about that too. They use this thing called hinted handoff.
Hinted handoff.
So imagine slipping that order under the vendor's door with a note that says, for server A.
Okay.
Please deliver this when they're back.
When they get back in the game.
Yeah.
I like it. Little message in a bottle.
Right.
But what if the server never comes back online?
So for those more permanent situations, they bring out the big guns.
Which is the Merkle trees.
Merkle trees. Yeah. Okay, I've heard of these.
Yeah.
They're like a big deal, right?
They are a really big deal.
Okay.
So picture this.
Okay.
Each vendor in our flea market keeps a special inventory log.
Okay.
But this log, it's not just a list of items.
Oh.
It's organized in this tree-like structure.
A tree.
That's the Merkle tree.
Okay. A tree-like inventory log.
Yes.
Interesting. Okay. I think I see where you're going with this.
Oh, okay.
How does that help with a server crashing, though?
So each branch of this tree represents a summary of the data stored below it, with the very top, the root of the tree, representing the entire inventory for that vendor.
Got it.
So when Dynamo needs to check if 2 replicas are in sync, instead of comparing every single item, it just compares the top-level summaries.
So just the top of the trees.
The roots of the Merkle tree.
Very cool. So if the roots match, then everything's good.
Everything's in sync.
And if they don't,
then we know exactly where to look.
It tells you where to go to find the problem.
Without this massive data comparison.
Oh, that's very cool.
Right.
So we've got our market, we've got multiple vendors selling the same thing.
Yeah.
And we've got our way to spot any differences.
What happens if a new vendor wants to join the market, or one of them has to like pack up and go home for the day?
So this is where Dynamo's elegant system for managing its network really shines.
Okay.
There's no central authority calling the shots.
No one's in charge.
Well, it's not that no one's in charge. They're using something called a gossip protocol.
A gossip protocol?
Yeah. So imagine all these vendors just like striking up conversations with each other.
Okay.
Hey, I saw server 4's open over there.
Okay.
I heard server 2's taking a break.
Okay, so like word of mouth, but for servers?
Exactly. Each server is periodically chatting with a random buddy.
Okay.
Sharing these little snippets of information about who's up, who's down.
Got it. So it's like the market has a mind of its own.
Exactly.
Very cool.
It's constantly adapting and self-organizing.
Okay, I like it. And that's how they know if a new server joins or a server leaves.
Exactly.
Very cool.
It's all done through this gossip protocol.
Love it. So we've covered how they actually store the data.
Yes.
How they deal with servers leaving and coming.
Right.
What about like me, the person at home,
Yes.
adding something to my cart?
So traditionally the client, that's like your web browser,
Right.
would send a request, like add this to my cart,
Okay.
to a load balancer.
Okay.
And this load balancer would be in charge of forwarding that request
Got it.
to the appropriate server.
So it's like the information booth at the flea market.
Exactly.
Got it.
But Dynamo takes a different approach.
Okay. How so?
Remember how we talked about the gossip protocol?
Yeah.
Where they keep everybody informed about who's responsible for what?
Right.
Well, Dynamo shares a mini version of that with the clients.
So I get a little map of the flea market.
Yes, you got it.
Oh, that's cool.
So you can bypass that information booth.
I don't have to ask where I'm going.
Exactly.
Okay.
And you can go directly to the right vendor.
That's awesome.
You know?
So it's faster for me.
Much faster for you.
And then less traffic for them.
Less traffic for them, exactly.
This is genius.
It's all about efficiency.
But my little map's got to be updated.
It does.
Right. What if something changes?
So the clients periodically check back in with Dynamo.
Got it.
To make sure they have the latest map.
Like every 10 seconds or something.
Yeah, about every 10 seconds or so.
Got it.
Yeah.
Okay, that's really smart.
So they've really taken that idea of client-driven coordination.
Yeah.
And they've really optimized the entire process.
Okay.
Especially for those read requests.
Okay.
When you're just browsing for items.
Right.
You know?
That's really cool. So they've thought of everything.
They've really tried to think of everything.
It seems like such a complex system to build.
Oh, absolutely.
I'm sure there were a lot of challenges along the way.
Building a system like this, it's like conducting a complex orchestra.
Okay.
You've got to make sure all the different instruments are in tune.
Right.
And they're all playing in harmony.
Yeah.
And one of the biggest challenges they highlight in the paper is balancing those background tasks with those critical foreground operations.
Got it. So in our flea market example,
Yes.
What would the background tasks be?
So making sure that all the vendors have enough change.
Okay.
The aisles are swept.
Okay.
There's enough parking.
Right.
These are essential for the market.
Right.
But they're not necessarily
customer facing.
Exactly. In Dynamo's world, those background tasks include things like replica synchronization.
Okay.
Making sure all those duplicate items are up to date.
Right.
Data handoffs when a new vendor joins the market.
Okay.
And they need to get their inventory up to speed.
So it's that balance of like keeping the lights on, but then also making sure that you're ready for the future. Exactly.
Got it. So how do they manage that?
That is a great question.
Because you don't want to do those things while people are trying to shop.
Right. You don't want to be restocking while people are trying to buy.
Exactly.
So it's like they have a dedicated crew managing all those behind-the-scene tasks, making sure they don't disrupt the flow of shoppers.
Okay.
They have this thing called an admission control mechanism.
The admission control mechanism, what's that?
It's like a bouncer for these background tasks.
Okay.
Only letting in the essential ones.
Got it.
Each task needs to get permission, basically, before it can start using resources.
Like disk space or...
Like disk space.
Database access, that kind of thing.
Exactly.
Got it.
And this admission controller...
is constantly monitoring the system's performance.
Okay.
Making sure everything is running smoothly.
Taking the temperature.
Exactly. If the controller senses that the market is getting too busy...
Okay.
Maybe a background task is taking up too much bandwidth.
Okay.
It adjusts... the resources that are available.
So it's like telling the cleaning crew to take a break.
Exactly.
While the vendors catch up on sales.
Precisely.
Got it.
It's all about finding that balance.
Okay.
Right. Making sure that those background tasks get done.
Right.
But they're not impacting the customer experience.
Customers are number one.
Customers are always number one.
Got it.
And remember how we were talking about those client updates that happen every 10 seconds?
Yeah.
That same principle of balance applies there too.
Okay, remind me, what were we talking about with those?
So we were talking about how the clients periodically check for the latest market map. Right.
Got it.
Now, you might think it'd be faster to have the servers just push those updates to the clients.
Right. So like as soon as something changes, I know.
Right, like a notification on your phone.
Right, exactly.
But imagine millions of shoppers all receiving constant updates.
Too much.
It would overload the system.
Yeah, that makes sense.
So Dynamo's designers, they recognize that A pull-based approach
Okay.
where the clients are checking for updates
Okay.
at regular intervals
Okay.
might seem slower,
Right.
but it's ultimately more efficient.
That makes sense.
It's scalable.
Okay. So it's like checking your mailbox once a day.
Exactly.
Instead of having the mailman ring the doorbell every 5 minutes.
Precisely.
Got it. Okay.
And this attention to detail,
Yeah.
this focus on making those smart trade-offs,
Right.
that's how they achieve
Yeah.
this incredible uptime
Okay.
and reliability
Got it.
at such a massive scale.
They've really thought of everything.
They really have.
Okay.
They knew that even with all its sophistication,
Okay.
Dynamo's current design might not work forever.
Okay.
Because as Amazon grows,
Right.
as they add more servers,
Right.
managing that network
Right.
with just a gossip protocol.
Yeah, it's like the word of mouth isn't going to scale.
Exactly. It's like
wood.
trying to manage a global flea market
Right.
by word of mouth.
Exactly.
So they hinted at using a hierarchical structure to address these scalability challenges.
So instead of one massive flea market, you have like a bunch of smaller ones.
Like a bunch of interconnected markets.
Right, exactly.
Each with their own way of communicating.
That makes sense.
And then they all talk to each other.
Got it.
It's this kind of forward thinking
Okay.
that has made Dynamo such a game changer.
Okay.
You know, it's not just a technical marvel.
Yeah.
It's a testament to adaptability,
Okay.
to constantly iterating
Right.
and improving
Got it.
on what works.
So it's about making those smart choices and understanding that like there's not going to be a perfect solution.
Exactly.
Right.
There's no one size fits all.
Right. It's about what works for you and what your priorities are.
Exactly.
So they're thinking ahead about how to solve those potential problems.
Yeah, and that is what makes it such a game changer.
Okay.
They're not just like, oh, this is the perfect system, we're done.
Right.
They're like, this works for us now, but it might not work forever.
Always iterating.
Exactly. And that's how they've been able to stay ahead of the curve.
Right.
And build something that's so incredibly reliable.
Okay.
And scalable.
It's really impressive.
It really is.
Well, on that note, I think we'll wrap up this deep dive into Dynamo.
Sounds good.
A story of smart engineering, smart trade-offs, and a commitment to keeping those virtual shopping carts rolling.
Absolutely.
Until next time, keep exploring, keep questioning, and remember, a little sloppiness
a little bit
can be the secret
It's true.
to building something truly resilient.
Well said.
All right. See you next time.
See you.